What's up, everybody? Let's do this. What I wanted. These must be integers.
That was a tough one. But So I wanted to give you a little glimpse on how I code and how I build things. And hopefully by watching me, you will see how I build just very small snippet of code, and I test a lot of and try at the end of the sword value if it needs to be. Because sometimes I make syntax error or spelling error, and if I do this, it gives me, it tells me the error. So everything seems to have gone well. So now I need to loop through the array. Okay, let's just do that and not worry about anything else, okay? Because my head is already just so focused on, let's just iterate this, okay? 3, 2, but I think I may need an index. I may need to access the index. So instead of this, I will do range from 0 to the length of array. And then just to make sure, let's just print this index I, and then the value is going to be R of I. Okay, and let's just save it and run it. So index 0, okay, this is good. I did a loop. Okay, so I did the first loop, and in the first loop I need to compare the left value with the right value, right? Okay, so, and now array has changed because I moved it manually. So 8 is no longer in the first last value, but let's just stick with it. I don't want to undo. So now let's compare the first value with the second value, or the left value with the right. So then what I would do is, let's just print comparing, and let's put the left value here, which is going to be R of I, and then R, the one on the right, is going to be I plus 1, right? Let's just do an if comparison. If, okay, if list of array of I is greater than this. If the left one is greater than the right one, what does that mean? It means that I need to swap it because I want the bigger number to be on the right? So then I will swap it. So traditionally, in order to swap two values in the array or list, you will have to create a temporary array. But there is a trick in Python, which is really cool. So hopefully you feel comfortable with swapping. If you don't, if you have never swapped a value using temporary, you got to learn how to do that. But if you're already beyond that level, then you can do a shortcut in Python where you can just simply do this. And what this means is you prepare these two values and you basically just set it like that. So multiple assignment. This is really cool. So let's just do that, and then let's say print and swapped, and then let's just print I. So as you can see, I do a lot of printing. Okay, and then that's it. So let's just see if it worked. So index 0. Okay, comparing 1 and 5. It seems like it didn't swap. So why do we do that? Let's just still print a message. No need to swap. And then let's just pass these two values, okay? So let's run it again. Okay, comparing 1 and 5. So no need to swap. Good. Okay, this is looking a little messy. So why don't I do this? Why don't I insert an extra line? So a new line, that's what it means. And then maybe to make this look better, why don't I also insert 80 stars? And then no, let's, yeah, that's okay, I think. And then also add a new line. Let's do that. And then let's clear this and run this again. Oh, there's an error. Okay, what did I do? Oh, yeah, this one I needed. Is that right? Index. No, that one. Okay, that's right. This. Okay, there you go. Okay, so it reads a little bit better. So let's look at the first one. index 0, value 1. Okay, comparing 1 and 5, no need to swap. Okay, so that's good. Now you should compare 5 and 3, right? Comparing 5 and 3, swap 3 and 5. Okay, good. So now this is sitting at, right, 1, 3, 5, and so forth. Okay, so okay, this is good. So it seems like I don't really need this. So maybe I'll just get rid of that because now this is kind of on the way. So maybe I'll just say, yeah, I don't really need to see this. And maybe swap and have it say the new array. Array is now, okay, so maybe that's, so let's run it again. And some of you would have noticed that I actually have an error, but it's okay. So let's look at this. Oh, and then okay, hold on. Let's do that nice trick over here. Okay, so it just looks nice. There we go. So comparing 1 and 5, no need to swap 1 and 5, that's good. Okay, comparing 5 and 3, swapped 3 and 5, so array is now 1, 3, 5, that's good. Now it's going to compare 5 and 2, and it should swap it, so it did swap it, good. And then it should compare 5 and 0, and it should also swap, so good. Okay, so it seems like it's working. And then there is an error here. What's going on? Well, you basically went over. There's when it's looking at this value and you're looking at the one right to it, there is not one right to it, right? So it seems like what could we do? Instead of going from 0 all the way to the length, we can just go -1. Okay, so let's clear this and run it again. And then it seems like after the second iteration, this is good. So it started out like this, and then it ended up like this. Okay, good. Okay, so I think the first iteration worked just fine, right? All right, so now this worked, so it seems to be going good. But now I gotta do it again, right? I don't have to do it all the way from 0 to the last one. Now I can just do it from 0 to this one. Okay, so let's put that in. So let's just create another variable called j, and then this one, no, maybe what we should do is, okay, what should we do? Because we need to, okay, so this one goes all the way from 0 to the last one. So what I can do is I can do 4j in range, and let's have this be length of array -1, and then what I can do is I do this and then -j, because j is initially 0, so I do it for length of array -1, and when I did one iteration, then j becomes 1. Now I just have to go from 0 all the way up to length of array -1 -1, right, and so forth. So I think that makes sense, and yeah, I think that should work. Well, let's just run it and then see. So, and then what we can do over here is we can say print, let's have multiple lines, and then have it display maybe this one, this times 100, so I can just see it more clearly, and then have it write iteration, right, iteration j. So if I do that, okay, that's a little bit too long. Let's maybe do 50 pixel or 50 times. Okay, so that looks a little bit better. So let's look. Okay, iteration 0, it didn't, and then that's what we've seen. It does iteration 1, and then it seems like it did move, right? It did swap it, which is good. Okay, and seems to be going, and it seems like that was it. Okay, so that worked, right? Okay, so that is my bubble sort. And then once I did it, I'm like, okay, this was good. So maybe I'll just comment out all the print. Right, there was no need to print. and this one I need to have it return the array, and let's have it print. So there we go. Okay, I can do some other things such as how many times did I run a logic. So if you're interested in that, you can do things like count, right? Let's say 0. I did, where did I put a dollar sign? And then you can say any comparison that you did. Let's just run, because any time that you come here, you're doing a comparison, right? So let's just increase it by 1 to see how many times I'm actually evaluating something, right? Running some logic. And of course you're running some logic here, but let's not worry about that. And then if you print number of evaluations, right, then we can look at count, and then let's run it again. So number of evaluations, because that was inside the for loop. I don't want that at the end. So then number of evaluations 15. If I have a really large array, let's say 10 times, you can see that it takes a lot longer, right? Let's say 1000. See how it's just running it, and it runs for a while, and it did how many comparisons before it's able to return. Okay, maybe 1000 was a little too much, but this is a good example that shows how efficient the bubble sort algorithm is, right? If the array is what is this? There's 9 arrays. So if there are 9,000 values in the array, see how my computer is still going? Wow. So there must be better ways to do sorting, which is correct, and that's why on some of these other assignments you can play with some of the other more efficient ways of doing sorting. But hopefully this gave you kind of an idea on how I code. And again, you do it very slowly. I finally had the answer. Look at that. But you just do it line by line. You're printing things along the way. You're not rushing things. You write a few lines of code and you go forth. And maybe before you submit, you can keep the print assignments, but look at how simple this looks if I didn't have any of the debugging, right? But would I have had any idea that the bubble sort would have looked like this? And would I start from the top and just write this at once? No, there's no way. I just do it line by line. I just do one thing at a time, and then that's how I come up with all of my assignments. Just line upon line, just do one thing at a time. Let's just write a few lines of code, print a bunch of stuff. Does that work? And then add another one, and so forth. Okay?
All right. Good to know. Interesting stuff.
Okay, let's talk about object-oriented programming. And one of the best way that you can learn about object-oriented programming is by thinking of computer games like Age of Empire. And this is a great game. It's one of my favorite games. And I did a Google search where you can see different images of this game. In this game, you can create different buildings. You can create different types of people, soldiers, farmers, and so forth. And you can have these unit go and fight each other and so forth. It's a great game and it's a lot of fun. Alright, so let's say you are a developer and then we want you to create a game like the Age of Empire. How would you go about creating a game like this? Well, first you kind of have to plan what different things you will have in the game. So let's say that we decide to have, let's just make the game very simple. Let's say that we decide to have 3 different types of buildings. So we'll say one's called a barrack. And the barrack can do different things. Mainly, it will create different soldiers that we can send off to fight different enemies. And let's say we also have a farm. And let's say we can also have a temple. Okay? Now when we look into each of these things, let's break it down even further into 2 categories. One is, what can each of these barracks have and what can it do? Or what can each farm have and what can it do? So what can the barracks have? Well, each barrack can have, let's say, an X and Y coordinate, and maybe the building itself has some type of health, so that when the enemy attacks, maybe initially the health is 100, and it goes down, and when the health is 0, then it destroys. Now, what can each barrack do? Well, it can, let's say, create soldiers, it can move, and it can also destroy. And there are probably other things that you can come up with that you can have each barrack have and do. And same thing with the farm. We can say each farm has an XY coordinate, maybe it has its own health as well, and maybe it has capacity which determines how much food it can produce each day. And farm can also move, it can also destroy, and so forth. Okay? Alright, so this blueprint that I created, this outline that I created in computer programming, that's called class. And class is merely a blueprint of what I want to do. And it has mainly two categories. One is, what can it have? And these are called attributes. And what it can do. And the do part, the functionalities, are called methods. Okay, and methods are just functions inside a class. Attributes are variables inside a class. Okay, so now that I have this blueprint, did this actually create any barrack, or did it create any farms or temple? It didn't, right? So what we're going to do is, now using this blueprint, we can create a barrack. So this is my barrack represented by a circle. I'm going to create another barrack and another one. So I created 3 different barracks using this. Now these objects that I created are also called instances. It's also called objects. Okay, so using the blueprint, using the class, I can create different instances or different objects. Okay, and sometimes they say off of the class you're instantiating an object, but in essence, instance and objects, they're exactly the same thing. And each of the instance can also, for example, it will have its own instance. Off of the class, you're instantiating an object, but in time called objects that I created are also called in this. Actually, and methods are just functions inside a class. Attributes are variables inside a class. Okay, so now that I have this blueprint, did this actually create any barrack, or did it create any farms or temple? It didn't, right? So what we're going to do is, now using this blueprint, we can create a barrack. So this is my barrack represented by a circle. I'm going to create another barrack and another one. So I created 3 different barracks using this. Now these objects that I created are also called instances. It's also called objects. Okay, so using the blueprint, using the class, I can create different instances or different objects. Okay, and sometimes they say off of the class you're instantiating an object, but in essence, instance and objects, they're exactly the same thing. And each of the instance can also, for example, it will have its own X and Y coordinate, and it can also it also will have these different functionalities. Okay, so the instance has its own X and Y, its own health. This instance, this barrack, will also have its own unique X and Y and health. And any of the variables, any attributes or methods that the instance has independently, those are called instance attributes or instance methods. Okay, so now a few more things. What if there are some attributes or some methods that you don't want the instances to have? So let's say, for example, that you don't want them to self-destroy and you still want this functionality, but you want to make it private. You don't want to make it available to these instances. Well, when you create these methods or functions, you can make them private. And when you make a method private, or when you make an attribute private, then these private attributes or methods are no longer can be accessed by the instances. Okay? Usually in many programming languages, if you just create default attributes and methods without specifying whether it's a public or private, it's automatically set as the public, and public attributes and methods are available within the class and also available to each of the instances. Okay? So we talked about how you can make any of these attributes public or private. Okay, let's introduce a few more terms. So what if there were some things that you wanted to do whenever you created an instance? Whenever you created an instance of the barrack, what if you wanted to give it a default X and Y health? Maybe you want to give it a health of 100, and when the enemy comes, you want that to go down a little bit. Well, there is a special method that you can implement called the constructor. And different languages does this a little bit differently. If I name my blueprint barrack, in some languages, if you have a method called barrack, then that's the program will automatically assume that's your constructor. And constructors are basically method that the program will run whenever you construct a new instance. So again, if you want to do something whenever a new instance is constructed, put that inside a constructor. And depending on what language you're using, just do a Google search and find out how you can create a constructor, whether you're using PHP, Ruby, Python, C# or Java or whatever. Okay? Alright, so those are what constructors are called. Some languages also have what's called destructor. And that's very simple. These are methods, or this is a method that is run whenever that object is later destroyed, when it is erased from memory, and so forth. Okay, few more concepts. Let's say that the barrack can upgrade, so it can move into a few different directions. Okay, so we start out with the basic barrack, and maybe later this becomes barrack 2, or it can also become another. Let's call it barrack B, and let's call this barrack A. Okay, and this is an upgrade, and it can do. It has everything that the barrack has. It can do everything that the barrack can do, but it just has few more. Okay, it has some additional attributes. It also has additional methods. This also has additional attributes and additional methods. Okay, off of the barrack. Okay, well, what I can do using object-oriented program is, instead of copying all these attributes over and starting, I can simply say, hey, I'm going to create a new class called BA and have it inherit everything that the barrack has and everything that it can do. Okay, and this is called inherit. And when we do inheritance, the class can basically inherit all the attributes and methods that the parent class has. Okay, and I can just specify additional attributes and methods in my child class. Okay, alright, now just one more thing. So let's say off of this BA, I created some objects like this. I created, let's say, 3 objects of this. And of course, this is going to have everything that I specified over here, as well as what I specified over here. Now, private method in the barrack, is that going to be available to this instance? It wouldn't be, because it's private for that. Okay, but will this private method be inherited to this blueprint itself, the BA blueprint? And the answer is no. Anything that's private inside the class doesn't get inherited. So what if I wanted these methods to stay private among the instances, but I still wanted to allow this to be inherited to my children class? Well, there is another property called protected. And if you say protected, you're protecting this among your children. It will still remain private among all the different instances, but it will allow your children class to inherit them. Okay, so here I'm going to put another method called protected. Okay, so in essence, that's what object-oriented programming is. And you can study different languages to study how different syntaxes are done, but using OOP, it allows us to create games like this, but it also allows us to organize our codes a lot better. And the example that I use is, for example, if you had 1 million photos and if you put it all in a single folder, that could be very confusing. Well, OOP allows us to, in a way, to create folders to organize our files. So instead of having 1 million files inside a single folder, now after you learn OOP, you know how to create a folder, how to put different functionalities into each of the folder, and that way you can organize your codes a lot better, create cool games like the Age of Empire, and make everyone happy.
Okay. Reading.
Okay.
succinct, succinct.